I was asked about this graphing question. It's number 5 from the graphing packet, and I think I can put together a pretty good example of this. So let's see what's going on here. The function's 2 sine of 3 theta minus 45 degrees plus 1. Notice that it's in degrees, so I am going to graph it in degrees, although most of the problems we're going to do after this section are going to be done in radians. Anyway, we can put together the amplitude, midline, phase shift, and period pretty quickly. The amplitude is going to be 2. It has been shifted up 1 unit, so the midline is going to be at y equals 1, or you can say it's been translated up 1. The phase shift, notice that the 3 has been factored out, which means it's the correct setup here, so it's been shifted 45 degrees to the right. Okay, and finally the period here, remember, is defined by that b multiplier. We know that the period is equal to 2 pi over b, but we're working in radians. I'm sorry, we're working in degrees this time, so it's going to be 360 divided by that b value of 3. It's going to be 120 degrees for the period, so it should cycle every 120 degrees. Basically, it's moving 3 times as quickly as it normally would. All right, the way I normally do these, and you're welcome to do it a different way if you want, but I focus on the intersection points along the midline, okay? And the regular sine function normally crosses the axis at 0, pi, and 2 pi, or I guess since we're working degrees here, 0, 180, and 360, okay? 2 things need to happen here. First of all, you need to take care of the period aspect of this, okay? Notice up here to get the period, we divided by 3, which means that we need to take these intersection points of 0, 180, and 360, and we need to divide each of those by 3. Okay, we're horizontally compressing this graph, and that's going to give us points of, I'm running out of space here, that's going to give us points at 0, 60, and 120. It'll finish the cycle, all right? But it's also been shifted 45 to the right, so I've got to add 45 to each of those points. So it's going to intersect the axis at, if we add 45 to each of these, it's going to intersect the axis at 45, 105, and 165, okay? And that's our unit there. So this is a little bit weird in the sense that the units here are a little bit odd. Let's see, from 45 up to 105, that's 60. It almost looks like 15s might be the way that I should be marking this off. So every 3 15s would be a 45, might be the way to go. So 15, 30, 45, 15, 30, another 45 at 90, 15, 30, another 45 at 135, 15, 30, another 45 would be 180, 15, 30, 45, that would give me a 225. And actually, I'm already out of the range here because this is supposed to cut off at 165, isn't it? Let's see, 165. Yeah, this isn't a great scale either, actually, now that I think about it, because I really need to have a 145, a 150, and a 165 on here. Yeah, I probably should count it off by 5s or 10s or something. Okay, well, I'll just label those points on the final graph. This maybe isn't the best way this could have been done, but it'll work. Okay, so remember, you draw the midline. Midline's going to go through here like this. At 1, it's going to intersect at 45. It's going to intersect at 105, which is actually, I guess, a third of the way. Well, I broke these up by 15, so actually 5s would just be a third of these. So 105 would be there, and then the final point there would be at 165. So 135 plus 15 would be 150, and then 165 would be another 16. That actually works. And we have that point right there. All right, so let's see, 45 plus 60, 60, those are evenly spaced out. All right. Okay, so we should be able to plot these high and low points in here and be done with it. The sine function is going to cross the axis at these places. And the amplitude needs to be 2. So it's going to go 2 units up. We're going from 1 up to 3, halfway between these 2 points right here. It needs to go 2 down halfway between these points. So let's see, that's going to be 2 below. It's going to go down to -1. And your function would look something kind of like this. Now, my graph is not the best that it could possibly be. So we're going to see that sort of thing happening. It really would be good to label these other points here. So this is the point 45, 1. I think that's clear to everybody. This point here was supposed to be the point 105, 1. Probably want to label it if it doesn't really show up on your scale, which mine didn't. And then this ending point here is 165, 1. Okay. And you really want your maximum and minimum points as well. So 135, -1. I guess that point really is already there. Okay. This point here should be halfway between 45 and 105. Okay. Which I believe if you average those two, 45 plus 105 is 150. 150 divided by 2 is 75. So this should be the point 75, 3. And anyway, I think that gets us all of our points. So anyway, in the ideal world, I probably would have counted this off by 5s or something like that. But anyway, that's the overall graph there. You can see we have a period that goes from 45 and ends at 165, and it's got a period of 120, which is what it's supposed to have. Amplitude is 2. It's been shifted 45 degrees to the right, and I think we've got all the features we need here.